Hello everyone and welcome back to the channel. So today in this video we'll be going to see how to simulate an AMR robot inside the Gazebo and to control it using joystick with teleoperation and to use the sensor data to provide an obstacle avoidance safety feature to this robot. So coming to the project description, this project builds upon the ROS2 From Scratch book, which is written by Edouard Renard, wherein we have created a project in the final chapter, and we are in this project extending the basic Gazebo mobile simulation into a more advanced autonomous mobile robot systems. So this particular project that we are doing, which is joystick based control and obstacle avoidance with the hyper sensor in the Gazebo simulation, allows us to spawn and control the robot inside the Gazebo using the joystick, and it allows us to integrate a real sensor data, which is ultrasonic sensor, through the Arduino, which communicates over the serial communication port. And with the help of that, we are enforcing a safety fallback feature that avoids the collision automatically. So coming to the hardware requirement, you would need a joystick, basically a wired or wireless, doesn't matter, just a joystick for input, an ultrasonic sensor to read the distance values. To interface it, we'll need an Arduino to allow the communication, and for that we need an serial communication cable, which is type A to USB B, which will connect to Arduino and then towards your laptop. Some jumper cables to allow the ultrasonic sensor to communicate with the Arduino, and this is optional, a breadboard to put the ultrasonic on top of, or either you could go with a soldering as well. So that is about the hardware selection and hardware components. So further, I've explained the code in the code explanation section. So there you would find all the important codes, and I'll encourage you to visit the GitHub link below on the repo, and you'd find the entire code there. Let us see the code explanation. Let's quickly walk through the code. So I'll only focus on important files because the code is already hosted on GitHub. So you can go there and have a look at the code. So let us first see the launch file, how it is structured, because this is the file from wherein we are going to load the entire system. So first thing first, we are going to provide the URDF path through which we are going to exactly locate where our URDF files are, and then allow the robot state publisher to use this URDF and create a robot description file. And similarly, we need the config path, so to define the configuration for Gazebo, because Gazebo requires a bridge to communicate with the ROS, because both are independent of each other. So that is why we have to create this Gazebo bridge YAML file, which basically allows ROS2 to talk to Gazebo or Gazebo to talk to vice versa. And other than that, we have to include the launch file for Gazebo. We have to launch the Gazebo environment. So here we are basically launching an empty environment, and then what we are doing is we are going to use the ROS Gazebo sync package to subscribe to the robot description, which is basically where the URDF files are, and it will allow the Gazebo to spawn the robot. And then again we have to call the node, which is ROS Gazebo bridge, and provide the YAML file which we have created here. And then we have to call the node sensor integration with the parameter serial port on which the Arduino is connected, AMR control to allow obstacle avoidance system, and lastly to include the teleop twist joy package, which basically is doing is it is fetching our controller inputs and then publishing it over CMD1. So let's see what all of these nodes are doing. So first thing is sensor publisher. Now the main objective of this node is to receive the data from the Arduino and then publish it over sensor data topic, which further is used in obstacle avoidance system. So basically what we are doing is we are creating certain parameters which you have already seen in the YAML file, serial port and baud rate we haven't defined there, but because it is a fixed baud rate that we are going to use. And then what we are doing is we are using the Python serial library, which allows us to communicate over the serial port. So here we are trying to communicate, we are trying to connect first to the serial port, and then once we are connected to it, what we are doing is we are listening to the serial port. If there is something available, then read the line, decode that line and strip that. It basically give us the entire message, and we are supposedly getting the message in int format. So we are expecting the message, but because serial communication provides string method, so what we are doing is we are typecasting that message into an integer, and then we are publishing it over sensor data topic. That's it for this serial communication node, and let's come to obstacle avoidance. Now here what is actually happening is, as you didn't remember, I've talked about this teleop twist joy package. So what it is doing is it's taking our joystick input through subscribing to joy command, and then basically it is publishing it over CMD valve. So what we are doing in this node is we are subscribing to that node and we are taking the CMD valve commands, which is basically the joystick raw inputs, and then we are also subscribing to the sensor data which is published by sensor publisher over this, and then we are providing our own velocity commands for the Gazebo to take them and simulate our robot inside. So basically when we receive the joystick inputs with the help of twist commands, we are going to save those inputs, and then when we receive the sensor data, we are checking if the distance is less than 10 centimeter. If it is less than 10 centimeter, then what will happen is we have to stop the motion. So what we are doing is we are setting the twist commands for linear x to 0 and angular z to 0, and we are publishing these commands 0 0, that is there is low motion possible, over CMD well safe. And if the sensor data is greater than 10, then what we are doing is we are basically just passing the raw joystick inputs which we have subscribed to CMD well. So we are just publishing the same inputs to CMD's well safe, which is then taken by Gazebo and it is used to drive the robot. You can see here in the bridge we have given CMD well safe, which is through our obstacle avoidance. So that's it for the course. Now you will see the demo. So now let us have a look at the demo. So let us go to the terminal and source our workspace, and let us run the command ROS2 launch AMR bring up and AMR launch.xml. So this will launch all the nodes together, including Gazebo and our two nodes of integration and obstacle avoidance. And for reference, let us in the second terminal we source the workspace again, and in this terminal we read the data which is published by the sensor publisher node. So ROS2 topic echo, because it is published on sensor data, and we shall receive all the data here. Let's enter, and the data is starting flowing inside the ROS2, and our Gazebo is also spawned the robot. So let us start the control. So now with the controller joystick we are moving the robot, and it is basically taking the joy node, and all the joystick inputs are passing to the joy node. And let us try to stop the motion. So I have placed my hand around the ultrasonic sensor, and you can see the data reach below 10. That is why even after moving the joystick the robot doesn't move. Now once the hand is off, you could see the robot moving inside the Gazebo simulation, and it easily works, and all the system is integrated well enough. So now let us for one more time put our hand on the sensor, and you can see the system is working and the robot has stopped moving. So this is all about the demo, and I hope you got to learn something about it. So this is the entire system, how it works and how it works together. So that's it for the video. I hope you like this video, and if there are any further ideas you can develop from this, then please put the comments below about it. And there is a link in the description for GitHub, so you could get the code from, and there is also a link in the description for my website that you can visit and see more projects like this. So thank you for watching till now, and consider like and subscribe if you like this video. Thank you.